Alright, I have included on here today for you some of their videos, links that they have, that my Math Lab has for you guys. I'm also going to include on it the class video today so that you can go back and rewatch it. Alright, everybody okay with that? Alright, perfect. So, I want you very quickly on your white when working. I would like for you to multiply those two binomials. Alright, let me see what you got. Alright, show me your answers. Alright, I see a lot of this as my answer. How many of us have that as our answer? Amazing. I'm very glad to hear it. Now, let's think about what we did to get this. Okay? Because in order to know how to go from here back up to here, we've got to think about what did we do to get from here down to here? Okay? So what did we do to get to this x squared? What did we do?
Multiplied x and x.
So we multiplied x times x. Everybody agree? Alright, so for the sake of common language today, alright? So for common language, we're going to call these right here, we're going to call those first terms. Okay? Because they're the first terms in the binomial. Does that make sense? So, for the sake of common language, those today are going to be called the first terms. Anybody want to guess what these are going to be called? They could be. I was going to call them last terms, but sure. Well, you want to call them second terms or last terms? What do you want to call them? Second terms? Okay, that's fine. Alright, so those are our second terms. So, using that common language, how did we get the x squared? We multiplied the two first terms. Alright, so to get that, we multiplied the two first terms. Can you get that door, please? Thank you. Now, how did we get the 12? How did we get the 12? Yes, David. Alright, we multiply the two second terms. Everybody agree? How did we get our middle term? How did we get this term? That's the question of the day. How did we get that term? Lala.
You multiply the first term by the second term, and then the second term by the first term, and then you added those together.
Okay, so what would you say that that is? This is the product of the first two terms. Everybody agree? This is the product of the last two terms.
Of the first and second.
What would this be? Damon, what do you think?
I was going to say the sum of the first and second terms and the second and first terms.
Okay, so we agree that it's the sum, right? What is it really the sum of, though? What? The last two terms. Now, mind you, we've multiplied them by x, so that's where the x comes in. But do we agree that the 7 is the sum of the last two terms? Right? Everybody agree with that? So the sum of the last two. Okay? Now, is it always going to work like that? Well, let's try it and find out. Let's try another one real quick. You ready? What if we tried this one? work that one and see what we get. I would work it on your paper, but that's just me. All right, are we ready? Okay, so based on what we just talked about, this is the product of the first two terms. Well, the first two terms are going to be what? X squared. This is the sum of the last two terms. Well, what's a negative 2 and a negative 7? A what? I'm doing the sum. Negative 9 what? X. And then this is the product of the last two terms. So a negative 2 and a negative 7 is going to give you what? Positive 14. Now, is that what you got when you worked it out? Well, let's find out. X and X is X squared minus 7X minus 2X plus 14. Combine my like terms. That's what I got. Does that make sense? So is this always going to work? Kind of, but now here's the problem. We've got to go from this back to this. All right, so let's look at how to do that. Everybody okay? So far, so good? All right, keep this in mind. Do you ever have this written down? Okay. If you don't, we'll write it down in just a split second. All right, so here we go. When we're factoring the trinomial, now, here's the kicker. It's got to be in this form. All right? It's got to be x squared plus bx plus c. Because what is my coefficient right here for this x squared? A 1. And we get x squared by doing x times x, right? So it's got to have that first term right there has to have a coefficient of 1. All right, now we're going to look at, in probably 2 or 3 days, what to do when this has a different number there. Okay? And I'll show you what to do there. But for today only, we're only looking at these where this is a term of 1. Okay, so the coefficient is 1. Everybody okay with that? Okay. Now, you know how we've had standard form, point-slope form, slope-intercept form, quadratic form? You know what I'm talking about? All these forms? Okay. This is called our trinomial form. It's x squared plus bx plus c. It's actually quadratic form. Okay? And I'll show you what we do with quadratic form as we go through this chapter and once we get into quadratics. But this is quadratic form because anytime it's an x squared, you know it's going to be a quadratic. Just like for it to be linear, it's going to just be a solid x. Does that make sense? No exponent other than 1. But when it's raised to the second power, that's going to be a quadratic. All right? So when it's in quadratic form with a being 1, here's how this works. All right? Keep in mind that if you didn't already have this written down, how did we get this? This was the what? The product of the first terms, right? Hold on, I'm going to rewrite that somewhere else so that I have it written. Okay, product of first terms. Everybody agree? How did I get this? Product of the second terms. Everybody agree? So here times here gave me C. Everybody agree? Well, how did I get BX? The sum of the last two terms. All right, now, there's a couple of things that you have to notice. I call this, and this is Embry language only, this is my first sign, and this is my second sign. Not seen. All right, so first sign, second sign. First sign tells me what what value B is, if it's positive or negative. Second sign tells me what value C is. Okay? Now, if I want this to be positive, and I'm getting a product, what can I multiply together to make C positive?
Two negative numbers.
Two negative numbers. What do we call those?
Positive.
Two positive numbers. Okay. So in order for me to make C positive, either my signs inside my binomials either both have to be positive, right? Because a positive times a positive gives me a positive. Or they both have to be what? Negative. Because a negative times a negative also gets me a positive, right? So how do I know when these both are going to be positive as opposed to when they're both going to be negative? What do you got? What do you think? When what's plus and minus signs?
If it's a positive number, then it's plus.
Which sign would be plus? The first sign or the second sign? Well, but if the second sign's a if the second sign's a minus, then I want this number to be a plus. So that means I either have to multiply two positive numbers to get a plus, or I have to multiply two negative numbers to get a plus, right? So look here. Here they both were positive, right? What happened? What ended up being positive? The C. Okay. What happened over here? Because the C ended up being positive here too.
We multiplied two negatives.
So how did I know that these were supposed to be negatives compared to these being positives? Yes, sir.
Because EX is a negative.
Okay. The BX tells you what your signs are going to be. All right, does that make sense? So, if I'm looking here and my C is positive, then I know both of these have to be the same. All right, if C is positive, you want me to write this down for you? Okay. Here we go. Huh? I'm going to tell you. Can you see the green?
Yeah.
I don't really like the green, but okay.
See what it looks like.
I don't like the green. Okay, hold on. I'm changing colors. Okay. If C is positive, alright, if C is positive, the sign for both binomials, alright, so Camille, look, see how these are going to become binomials? So the sign for both binomials, so both of these signs right here, okay, does that make sense now? Alright, so if this C is positive, the sign of both of these binomials
Be the same.
not only have to be the same,
Have to be positive or negative.
well, how do we know which one? They have to be the sign of the BX. Okay? Everybody okay with that? Alright, I'm telling you a lot of information. Alright, and then we're going to look at some examples. Are we ready? Okay. I don't want to erase all of this. I just want to erase some of it. Okay. So here we go. Are you ready? We know that this is going to factor into what? We know it's going to factor into what? What are we making? We're taking a trinomial and we're making it into what? Two binomials. So here's kind of how I think of this. When I see this, I automatically go ahead and write my two binomials. Okay? And when I write my two binomials, what do I already know? We got to remember there's going to be 4 terms here and 2 signs. What do you automatically know just by looking at that particular what do I automatically know? Lila, what do you automatically know?
That the 2 second terms are going to be shorter.
Okay. What else do you know? What do you know about what we're going to put right in here? Exactly, because this is an x squared, this is going to be x, and that is going to be x. That is the only way we can multiply to get x squared. Everybody agree? That's it. That's all we can do. Now, here's the next thing that you automatically know. You automatically know that because C is positive, does everybody see that? C is positive. That because C is positive, the sign for both binomials, so both of these signs right here, have to be the same as BX. So what's BX? Positive. So because that's positive, both of these are going to be positive. Everybody agree with that? Yes. Right? Now, how did we get the 12?
Well, like, it would be like 3 and 4.
How did we get the 12? We multiplied. We multiplied what's here by what's here. Everybody agree? Now, what can I multiply together to get 12? 1 and 12, 2 and 6, 3 and 4. Oh, so wait, we've got choices.
3 and 4.
Hold on, we've got choices. So here's what we have to do. Alright? You know the other day how we wrote out our factors to find our greatest common factor? We're doing that again. So over on the side, what you'll do is you'll write out your factors. So we got 1 and 12, 2 and 6, 3 and 4.
3 and 4.
Now, Allie says 3 and 4.
Because it's 7x.
Because what's 7x?
The BX.
Alright. So not only do we have to multiply to get 12, we also have to do what? Add to get BX. And BX has to add up to what? 7. Well, 1 and 12 adds up to what?
13.
2 and 6 adds up to, and 3 and 4 add up to 7. So that's the one I know I want to use. Does that make sense? So, what am I going to put right here? A 3. What am I going to put right here? A 4. Now, I know your question, so hold that thought. His question is, does it matter where I put the 3 and where I put the 4? Is that your question?
Yeah.
Of course it was. Okay, so, does it matter where we put the 3 and where we put the 4? Here's the thing. Multiplication is a commutative property, right? So it doesn't matter which way you do it. When both of these are the same, and when both of these are the same, it does not matter. There will come a time today where it will matter, and I will show you what that looks like, okay? But when these are the same and these are the same, it doesn't matter if you have x plus 4 first, and then x plus 3, or if you have x plus 3 and then x plus 4. Okay? Does that make sense? Yes or no? Okay. You ready to try one more? Alright, let's try this one together. We're going to do it together, so it's still on your paper. Don't get your white one working ready just yet. Okay. What do we automatically know? What do we automatically know? What should I make and do first? Miss Bandy, what do you want to do first? Make the binomials. All right. What do you know about the inside of your binomials, Miss Bandy?
The first term is above.
Okay, if the first term is x on both. Have we really done any math so far? No. All right. But we're a third of the way done. All right. What else do you know? Yes, sir. Okay, but not just because the Vx is positive, but because the what? The C is positive. If the C is positive, then we're going to be adding, okay? And if the C is positive, then we look to the B to see what it is that we need. So they're both going to be positive. Luke, honey, what's your question?
What if the C is negative?
We're going to talk about that, okay? But I wanted to start easy today. And so we're going to start with it because it's easier to do when it's positive. So we're starting there. Okay? Now, what do I have to deal with the 6? What do I need for this 6 to happen? I need for it to what?
You have to divide.
No. Multiply. I have to multiply to get 6. So what do I do? What can I multiply to get 6? 1 and 6. 2 and 3. I know you're not going to want to list your factors. Dude, I need you to list your factors. Okay? Trust me. Trust me. All right? Just have a little faith. List your factors. It will make your life easier in a couple of days. Okay? So just trust me. Not only do I need them to multiply to be 6, I also need them to do what? Add up to be 5. How did you know to add them? C tells you whether to add or subtract. If C is positive, you add. If C is negative, what do you think you do? Subtract. Okay? So I'm adding to get to 5. Well, 1 and 6 gives me what? 7. 2 and 3 gets me 5. So, does it matter where I put the 2 and the 3? No. So, I just usually go 2, 3. I mean, it's just habit. Everybody okay with that? Yes or maybe? All right, we good so far? So far, so good? Yes, no, maybe? Okay. All right, so then what I want you to do, can I clear all of this? Are you okay if I clear all of it? Okay. So what I want you to do is I would like for you to do these 2 on your whiteboard working.